Hi everybody, we're going to be doing something that you recognize, the Pythagorean Theorem. Now I know we're going to end up skipping this point for today. It's not going to be fully skipped, it's just that I think it will be a little bit easier to understand, plus it's going to be used for when we can't do the Pythagorean Theorem, and I think we might as well just start with something that we do recognize first, rather than get into something that we don't really know yet. So the first thing is I'm going to show you the proof of the Pythagorean theorem, how we know that it works. So I have this picture here, and what we're going to do is we're going to find the area of the big square in two different ways. So the first way, what we're going to do is we see that all the sides are going to be a and b, so together we know that's going to be a plus b. And the area for a square is of course going to be its side squared. So a plus b times a plus b, which then we can turn into a plus b squared if we wanted. It's not really necessary though. Anyway, we're going to FOIL this out. So we're going to get a squared plus ab plus ab plus b squared. And if we simplify that, we know that we're going to get a squared plus 2ab plus b squared. So there is our first way to represent the area of the big square. Now the second way that we're going to do it is we've put this smaller square inside, and then we also have four right triangles. So what we're going to do is we're going to find the area of the yellow square and the area of the blue triangles, and then if we add those together, that should give us an area then that is the same as that. So what we're going to do then, we know that for one triangle, that is 1/2 times the area of, 1/2 times the base times the height, so it's going to be AB. But we have four triangles, so we just need to multiply that by 4. So 1/2 times 4 means that we're going to get 2AB. I'm going to draw a box around there just so I remember to go back to that later. Now we need the area of the small square, and that part is going to be very simple for us because both of the sides are c. So we know for that then it's just a equals c squared. Then if we put it together and we find the area of the big square, that's the 2ab and it's the c squared. So we just add those together. Now the last part, these right here are supposed to be the exact same. So what we should do is we should set them equal, and we should simplify to see what will happen. I've got a squared plus 2ab plus b squared equals, and then it will be, oh, I've kind of run out of space here. So it will be 2ab plus c squared equal to that. We can subtract 2ab from both sides, and now you'll see it. We have found that a squared plus b squared is equal to c squared. And that's the Pythagorean theorem. So in this first example then, we're not given any numbers, but we are asked to find the length of the diagonal. Since this is in a square, we know that we've got a right triangle there, and in fact is an isosceles right triangle. Both of the sides are b, so we can start this by doing b squared plus b squared equals d squared. Then we're going to add the b's together. We get 2b squared equals d squared. Then we just need to take the square root of both sides. Over on the left then, we're going to get square root of 2 and square root of b squared after I break that up. And then over on the right side, we already know square root of d squared is just d. And when we simplify, we're going to get that square root of 2 times b is equal to d. Okay, in this problem then, or in these two problems then, I want you to try it on your own. Pause the video, and when you are done, start the video again and I'll show you how to solve them. Okay, for the first one then, some of you may have known the answer before we even got started, and that's going to be 8. So if you didn't know that, that's okay. We can still solve it with the Pythagorean theorem. We would have had 6 squared plus x squared equals 10 squared. Then we have 36 plus x squared is equal to 100. We subtract 36 from both sides, and we're going to get x squared equals 64. And then finally, if we take the square root of both sides, that's going to show us that x equals 8. Okay, now for the second one. So we need to square all 3 of the sides then as part of the Pythagorean theorem. So we know first that we're going to have x plus 1 quantity squared plus x plus 2 quantity squared, and that's equal to 2x plus 1 squared. Now we have to be careful when we square these. This first one is not x squared plus 1. This one is not x squared plus 4. This one is not 4x squared plus 1. That is not how we square binomials. Instead, what we're supposed to do is we need to FOIL each of these. So it may be useful to write them out the long way just to make sure that we're doing it correctly. Now we are going to run out of space here, but I'll try to squeeze it all in. It's not good, but hopefully you can understand what I was trying to do there. So in the first part, when we FOIL that out, we are going to get x squared plus x plus x plus 1. This second part is going to be x squared plus 2x plus 2x plus 1. And then the last part we're going to get is 4x squared plus 2x plus 2x plus 1. So when we simplify, over on the left side we are going to get 2x squared, and since there's a lot of stuff in here, let's cross them off as we get rid of them. Then we're going to have to add all of our x's together, and that's going to give us 2, 4, 5, 6. And then lastly, 1 plus 1 is going to give us 2. Then over on the right side, that one's not going to be so tough for us. 4x squared plus 4x plus 1. Let's see. Oh, I'm sorry. I made a mistake here. That should have been a 4 there. And so this should have been a 6. 5. Wow. Not doing so well here. Okay, now what we're going to do, since we have something squared, I'm thinking we might need a factor. So let's move everything over to one side. Let's subtract 2x squared, subtract 6x, and subtract 5 from both sides. And so what will happen is that we're going to have 0 equals 2x squared minus 2x minus 4. Before we start factoring it into two binomials, I noticed that all 3 terms are even, and therefore we can take a 2 out. And by doing that, that means that we can avoid doing the rectangle and the diamond, because now we just need to figure out what numbers multiply to be -2 but are going to add to make -1. I know that for 2, all we can get is 2 times 1, and if we want to add those to make -1, we have to have a -2 there. So then this will factor into 0 equals 2 times x minus 2 times x plus 1. For that first part then, we're going to get x equals 2. For the second part, we are going to get x equals -1. -1. And we're not quite done yet, because we need to check if both of these work. Now, the 2 is going to work. All of the sides are going to be positive. If we checked with the Pythagorean theorem, we're going to end up having a 3, 4, 5 right triangle. So that one is good. But then for -1, I can see that that right there is going to be a problem. -1 plus 1, sorry, not writing that well. -1 plus 1 is going to be 0. That side won't exist. So therefore, we know that -1 is not a possible solution. our only answer we can get is x equals 2. Okay, so a couple things then that we need to know about as well. The triangle inequality theorem. So for the three sides of a triangle, A, B, and C, A plus B will always be greater than C. So two sides must always add to be larger than the third side. So some examples here. The first one, 1, 2, and 3. Well, I know that 1 plus 2 does not end up being greater than 3. So I know that no, 1, 2, and 3 cannot be the side lengths for a triangle. Then for the next one, we have 7, 7, and 13. If we do 7 plus 7, that ends up being greater than 13. So that one is a yes. And then for the last one, 8, 10, and 12, that one definitely is going to work because 8 plus 10 is easily bigger than 12. So yes, that can also make a triangle. Now below them, we have the Pythagorean triples. I kind of mentioned this earlier because we had a question with a 6, 8, 10 triangle. So 3 whole numbers that make the Pythagorean theorem true. So 3, 4, and 5, that will work. And by the way, any multiples of 3, 4, and 5 will work as well. So if we have 6, 8, and 10, we could do, let's see, what else? We could do 12, 16, and 20. If you wanted, you could even double that again and make 24, 32, and 40. That would be a Pythagorean triple. Other common ones you're going to see are 5, 12, and 13, and then the 7, 24, and 25. Just so you know, the lowest numbers you'll ever see as a Pythagorean triple is the 3, 4, 5. So if you ever happen to see any combination of sides then that is not 3, 4, 5, like if they're lower, kind of like this 1, 2, 3, you should automatically know then that can't be a right triangle. So, for example 4 then, we are supposed to identify if these can make a right triangle or not. And if so, we're supposed to identify then the hypotenuse. So for part A, that one's easy. That one's the Pythagorean triple, because I just showed you right here, 3, 4, 5 makes a right triangle. So the answer is yes. And the hypotenuse is always the longest side. So that means then that 5 has to be the hypotenuse. And again, the hypotenuse is the side across from the right angle. So that's always the hypotenuse. Okay. Next one then, B. Oh, I should probably go in the same order that we have them here. So B. So we have 9, 16, and 25. Well, an easy way to check would be to try to divide all of these numbers by the same value and see if we can get to one of the Pythagorean triples. And I'm noticing that that's not going to be possible. 9, 16, and 25, that's actually 3 squared, 4 squared, and 5 squared. So that's giving me an idea that this is not going to work. But another way that I can figure it out is just by putting it into the Pythagorean theorem and seeing if it works. So if we do 9 squared plus 16 squared and 25 squared, and then we check those, we're going to get 81. 16 squared is 256, and 625 is going to be 25 squared. And those definitely do not add together to make 625. So the answer for B, no, those cannot make a right triangle. All right, for C, there's 2 ways that we could show that this is not going to work. The first way, that triangle inequality theorem, 1 plus 1 is not greater than 2. So because of that, I automatically know that the answer is no. But if you wanted, you could also go ahead and put into the Pythagorean theorem, does 1 squared plus 1 squared equal 2 squared? What we're going to find is we get 2 and 4, and those don't work. So that's another reason then why it cannot be a right triangle. And for A, I should have written that that was a Pythagorean triple. Then the last one, 7, 24, and 25. And that one also is going to be a Pythagorean triple. The longest side is the hypotenuse, so it's going to be 25. Okay. So what I want you to do then is take a look at these and identify which combination of side lengths could work for a right triangle. Pause the video. When you are done, I will give you the answers. Alright, so pretty much just the best way of going through this is to just put all of them into the Pythagorean theorem and see what we get. So the first one, 10, 12, and 14. We're going to get 100, 144, and the last one, I'm going to double check, but I'm pretty certain that's 196. Yes. And we can see that this definitely is not going to work because we would have had 244, and that does not equal 196. So that first one, I'm going to cross it off. That one is a no. Okay, so for the second one then, we have 9, 12, and 15. Well, part of what's going to help is that up here, oh, I didn't actually write it, my mistake. But 9, 12, and 15 is actually going to be a multiple of the 3, 4, 5 right triangle. Even if you didn't see that, we can just put it into the Pythagorean theorem. Equals 15 squared. We're going to get 81 plus 144, and we want to check if that is equal to 225. And indeed it is. So we know that this one works. Alright, then we're going to try 25, 60, and 65. So 25 squared is 625. 60 squared, 3600. And then I actually don't know 65 squared off the top of my head, so I'm going to check that. And that is 4,225. And if we add those together, those do end up being the same. So yes, that one is going to be making a right triangle. And then lastly, we have to check 12, 15, and 20. That one, we actually had 12, 16, and 20. So that right there is going to show us that no, it's not going to be a right triangle, but we could still go ahead and solve it with the Pythagorean theorem just to be sure. And we've got, there's no way that 144 and 225 can add together to make 400, because it actually ends up being 369. Okay, go ahead for this one. I want you to try to find the length of the diagonal in this shape if you know the perimeter is 72 and you know the width is 16. Okay, so if we know that the width is 16, we should just go ahead and fill that in. And we know that the perimeter is going to be the sum of the four sides. So to find the length, it's going to be 72 equals 2 times L plus 2 times 16. So then as we solve that, we know that we're going to get 72 equals 2L plus 32. We subtract 32 from both sides. We're going to get 40 equals 2L. And if we divide both of those by 2, we get 20 equals L. So now that we have that, we can fill it into the rectangle. And looking at this then, I'm not entirely sure what that is off the top of my head, so we're going to have to throw it into the Pythagorean theorem. We don't have the hypotenuse, so it's going to be 16 squared plus 20 squared equals, and I'm just going to call the hypotenuse h, so h squared. Okay, so 16 squared is going to be 256. Then we get 400 for 20 squared. You have 656 is equal to h squared. And so the square root of that is going to be equal to h. Now, in order to simplify that, what I see, I think this might be divisible by 4. So in order to figure out if it's divisible by 4, you look at the last two numbers. 56 can be divided by 4. And in fact, when we divide that by 4, we get 164. And then I see that we can divide it by 4 again, because if we cover that up, 64 can be divided by 4. And when we do 164 divided by 4, that is going to get us 41. And then 41 cannot be simplified any further. So the last part then, we can simplify square root of 4 times square root of 4. That is just 4, so the answer is 4 times the square root of 41. Okay, this one I know it says that it's going to be an activity, but I'm actually going to show you how to solve this. So it says that the diagonals of the rhombus are 8 and 15, and what we're going to do is we are supposed to find the perimeter for this rhombus. So an important thing about a rhombus is that all 4 sides are congruent. So yes, a square is a type of rhombus. However, not all, the plural of rhombus is rhombi, not all rhombi are going to be squares. And in fact, this one clearly is not a square. Now the next thing is that we know that the lengths of the diagonals are 8 and 15. So that right there is supposed to be 8. This right here is 15. So what I noticed then is we can just cut those in half, and we're going to put a 4 here, and half of 15 is 7.5. And we can use Pythagorean theorem in order to find the hypotenuse, which ends up being the side length of the rhombus. So we're going to get 4 squared plus 7.5 squared is equal to h squared. And I don't know 7.5 squared, so 56.25. When we add those together, we get 72.25, and so the square root of that is going to be the value of the one side length. So, oh, excuse me, I didn't do the correct square root. That actually works out really nice. It turns out that is 8.5. So if we have 8.5 for the hypotenuse, that means that all of these sides in the rhombus are 8.5. And we just need to multiply by 4, and that gets us the full perimeter. And that is going to get us then 34 centimeters for the perimeter. All right, so that's everything. Your homework is going to be a worksheet then on the Pythagorean theorem. Again, on Schoology, I'm not sure if I'm